Good afternoon, Doc. Good afternoon, classmates. So I am Alvi Basanias, and my report for today is all about standard deviation and the computation of standard deviation from ungroup data using machine formula. So first, let us discuss what is a standard deviation. Standard deviation is a measure of the amount of variation or dispersion of a set of data values relative to its mean. So a mean is a simple mathematical average of a set of two or more numbers. So if you still remember our last topic or lesson about mean, so you already knew how to get the mean. So to get the mean, we will just sum or add all together the number in a set of data and then divide it by the total number or number of cases. So that's how we get the mean. Standard deviation as another measure of variability is the most commonly used indicator of the degree of dispersion and also the most dependable measure of variability. So the standard deviation is calculated as the square root of variance by determining each data point's deviation relative to the mean. So standard deviation is the square root of variance. So maybe you are a little confused of how standard deviation is the square root of variance. So that is why I have here, or I prepared a little example or computations of how to get the standard deviation through the square root of variance. Here, an example of standard deviation. So let's say that we have the data points of 4, 6, 7, 9, and 10. So we suppose that these are the score of five pupils who took a quiz and science subject. So what are we going to do here is the first, let's make a table to help us to compute our standard or to get our standard deviation. So the table has four columns. So the first column is for the students, and then the second column is the x, which is the score, and then the third column is the difference between the score and mean, or x minus x bar, and the fourth column, it is the square difference of scores and mean, or the x minus x bar squared. So the first column, which is the students, so since we have 5 students, so let's put 1 2 3 1 2 3 4 and 5, and then the x, which is the score, so let's put 10 9 7 6 and 4. So before we can proceed to our third and fourth column, we need to get first our arithmetic mean in the data set. So the formula of mean is x bar is equals to summation of x divided by n. So to get the summation of x, or the score, we need to add all the data score in the second column. So 10 plus 9 plus 7 plus 6 plus 4 is equals to 36. So now we have the summation of x, which is 36. So our n, or number of cases here, is a 5, which is a 5 students. So the given is summation of x is equals to 36 and n is equals to 5. So let's substitute. So the summation of x is 36. So we put 36 here, and n is a 5. So let's put a 5 here in the denominator. So now let's divide 36 by 5. So 36 divided by 5 is equals to 7.2. So now our mean is 7.2. So since we already have our mean, let's now work for our table 3, which is x minus x bar, which is score minus the mean. So our x here is the score. So we put the score in the left side, and then the mean, which is 7.2, here on the right side. So to get the difference between the scores and the mean, let's subtract now the 10 minus 7.2 is equals 2.8. 9 minus 7.2 is equals 1.8. 7 minus 7.2 is equals negative 0.2. And 6 minus 7.2 is equals to negative 1.2, and 4 minus 7.2 is equals to negative 3.2. So now the difference between the x and the x bar, or the score and mean, is this 2.8, 1.8, this is negative 0.2, negative 1.2, and negative 3.2. So now we already have our data in column 3. So to have the difference, or the square difference of score and mean in the column 4, we need to subtract. We need to multiply the result in the column 3. So to multiply, so let's multiply it by itself. So 2.8 minus 2.8 times 2.8 is equals 7.84. 1.8 times 1.8 is equals to 3.24, and negative 0.2 times negative 0.2 is equals to 0.04, and negative 1.2 times negative 1.2 is equals to 1.44, and then negative 3.2 times negative 3.2 is equals to 10.24. So now we have now our square difference of score and mean in column 4. So to get the summation, or sum of the square difference of scores and mean, we need to add all together the data, or the number here in the column 4. So let's add. So 7.84 plus 3.24 plus 0.04 plus 1.44 and plus 10.24 is equals to 22.8. So the summation of square difference of scores and mean, or the sum of x minus x bar squared, is 22.8. Now that we already have our summation of the square difference of scores and mean, or summation of x minus x bar squared, which is 22.8, and our number of cases n, which is 5. So now let's start to compute our variance. So with the use of this formula, SD squared is equals to summation of the square difference of scores and mean divided by n minus 1. So our summation of x minus x bar squared is 22.8. So let's substitute. So let's put 22.8 here, and then our n is 5. So let's put 5. So now we're going to subtract. So the first thing that we need to do is, so let's subtract 5 minus 1 is equals of 4. So we have now 22.8 divided by 4. So 22.8 divided by 4 is equals to 5 5.7. So our variance is 5.7. So if you still remember what I had said earlier, that the standard deviation is the square root of variance. So because if we get the square root of this 5.7, the result of this is our variance. So the square root of 5.7 is 2.387467. So for you to understand more, to be clear more, for you to make it clear for you, I will show you the computation of standard deviation using the standard deviation formula. So the formula of standard deviation is SD, or standard deviation, is equal to square root of summation of x minus mean, which is x bar squared divided by n, which is the number of cases, minus 1. So it is equals to square root of the sum of x minus x bar squared divided by n minus 1. So now let's substitute with the use of the same data. So our summation of x minus x bar squared here is 22.8. So let's put 22.8, and then n is 5. So let's put 5. So now we have square root of 22.8 divided by 5 minus 1. So the first thing that we do is to subtract 5 minus 1 is equals 4. So now we have square root of 22.8 divided by 4. So let's divide first the 22.8 by 4. So 22.8 divided by 4 is equals to square root of 5.7. So the last step is to get, or to take, the square root of 5.7. So the square root of 5.7 is equals to 2.387467. So if you have noticed that variance is closely related to standard deviation. So the only difference between these two formula is that the standard deviation involves taking the square root of the calculation, while while on variance we don't take the square root. And also notice that we denoted standard deviation as SD, while the variance is we denoted as SD squared. So both of these can be referred to us as sample variance and sample standard deviation. Standard deviation is denoted by lowercase Greek sigma, or SD, or sometimes S. So what does the standard deviation even tell us? So what standard deviation tell us is that how close the values in a data set are to the mean. So for example, if we have a small, or we have a low standard deviation, it indicates that the values tend to be closer to the mean. So a small standard deviation indicates a small amount of variability for a given data set. So in other words, there will be a lot of values that are closer to the mean, so which makes the distribution of value is less spread out. So if you have noticed here in the illustration, this is how the low standard deviation looks like. So the distribution of values is less spread out, so they are tightly clustered around the mean. So in contrast with that, a high standard deviation indicate a high amount of variability in a given data set. So in other words, there will be a lot or more of values that are farther from the mean, so which makes the distribution more spread out. So a high standard deviation indicates that the values are spread over a wider range. So if you see here in the illustrations that I had made, the distribution of the values is widely dispersed. This will be explained more by the next reporter on how to interpret the standard deviation below and above the mean. So the low standard deviation indicates that the values tend to be close to the mean, also called the expected value of the set, while high standard deviation indicates that the values are spread out over a wider range. So properties of standard deviation. So when using standard deviation, always keep in mind the following properties. So standard deviation is only used to measure spread or dispersion around the mean of a data set. So second, standard deviation is never negative. Third, standard deviation is sensitive to outliers. A single outlier can raise a standard deviation and in turn distort the picture of spread. When you see outlier, it is a data point that lies outside the overall pattern in a distribution. So next, for data with approximately the same mean, the greater the spread, the greater the standard deviation. And then next, if all values of a data set are the same, the standard deviation is 0 because each value is equal to the mean. So now let's go to my next topic, which is the computation of standard deviation from ungrouped data using machine formula. So like variance, standard deviation from ungrouped data has two methods, which is the machine formula and the working formula methods. So this working formula method, I used this earlier to show an example of how the standard deviation and variance are related to each other. But this method will be explained more by Ms. Mahinay. So the step and formula are almost the same with the variance, as they only differ in the square root sign. So the last step is the extractions of the square root. So this is the formula of standard deviation from ungrouped data using machine formula. So SD is equals to square root of sum x squared minus CF divided by n minus 1. So SD stands for standard deviation equals square root of the summation of squared x minus correction of factors divided by number of cases minus 1. Now let's look at the example of standard deviation from ungrouped data using machine formula. So the teacher wants to know if the students understand the lessons in science. In order for the teacher to determine if most students understand the lesson at the same level or if there is a high standard deviation, the teacher give an 85-item test in science taken by 20 students. So the scores for the test were 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85. So before we get the standard deviation, let's find out first what are the steps in getting the standard deviation using machine formula. So the steps of getting the standard deviation using machine formula are as follows. Step 1, multiply each score by itself to get x squared. Step 2, look for the sum of x to get the summation of x. Step 3, add the results in step 1 to find the summation of x squared. And step 4, solve the correction factor of CF by using the formula, which is CF is equals to summation of x squared divided by n. And then step 5, apply standard deviation from ungrouped data using machine formula, which is the SD is equals to square root of summation of x squared minus CF divided by n minus 1. So we can proceed step 5, or we can get the standard deviation after we get the correction factors. So that's the steps on getting the standard deviation. SD is equals to standard deviation. Summation of x squared is equals to sum of squared x. CF is equals to correction factor, and n is the number of cases. To find the standard deviation, first I made a table to present our data or the set of scores. So table will help us to compute our to compute and to get our standard deviation. So on the first column, it is for the students. So since we have 20 students, we're going to put here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the second column is for x, which is the score. So since we have the highest score of 85, so we're going to put here 85, 84, 83, 82, 81, 80, 79, 78, 77, 76, 75, 74, 73, 72, 71, 70, 69, 68, 67, and 66. So according to the steps, the step 1 says that we need to multiply each score by itself to get the x squared. So now let's multiply each score by itself. So 85 times 85 is equals to 7,225. 84 times 84 is equals to 7,056. 83 times 83 is equals to 6,889. 82 times 82 is equals to 6,724. 81 times 81 is equals to 6,561, and 80 times 80 is equals to 6,400. 79 times 79 is equals to 6,241, and 78 times 78 is equals to 6,084. And then 77 times 77 is equals to 5,929. 76 times 76 is equals to 5,776. 75 times 75 is equals to 5,625. 74 times 74 is equals to 5,476. 73 times 73 is equals to 5,329. 72 times 72 is equals 5,184, and 71 times 71 is equals to 5,041. 70 times 70 is equals 4,900. 69 times 69 is equals to 4,761. 68 times 68 is equals to 4,624. 67 times 67 is equals to 4,489. 66 times 66 is equals to 4,356. So now that we have our x squared in the third column, now let's go to the step 2. So according to the step 2, we need to look for the sum of x to get the summation of x. So the step 2 is to add all together the scores of the students. So now let's add 85 plus 84 plus 83 plus 82 plus 81 plus 80 plus 79 plus 78 plus 77 plus 76 plus 75 plus 74 plus 73 plus 72 plus 71 plus 70 plus 69 plus 68 plus 67 plus 66 is equals to 1,510. So the summation of x, or the summation of score here, is 1,510. So the step the step 3, which is the add the result to step 1 to find the summation of x squared. So the result of the step 1, which is here on the column 3, so we're going to add this to get the summation, or to find the summation of x squared. So now let's add all together. So 7,225 plus 7,000 56 is equals to 14,281 plus 6,889 plus 6,670 6,724 plus 6,561 plus 6,400 plus 6,241 plus 6,084 plus 6,000 plus 5,929 plus 5,776 plus 5,629 plus 5,476 plus 5,329 plus 5,184 plus 5,041 plus 4,900 plus 4,761 plus 4,624 plus 4,489 and plus 4,356 is equals to 114,670. So our summation of x squared is 114,670. So now that we are done on step 3, so let's go to step 4. So according to step 4, we need to compute or solve for the correction factor with the use of this formula. So the formula of correction factor is CF is equals to summation of x squared divided by n. So our summation of x is 1,510 and our n is 20. So now let's substitute. So we have now 1,510 squared divided by 20. So the first thing that we need to do is to get first the squared of 1,510. So 1,510 squared is equals to 2,280,100. So now we have 2,280,100 divided by 20. So next is let's divide. So 2,280,100 divided by 20 is equals to 114,005. So our correction factor is 114,005. So since we have now our correction factor, so now we can proceed on getting our or finding our standard deviation. So in step 5, let's apply standard deviation from ungrouped data using machine methods. So the formula is as SD is equals to square root of summation of x squared minus CF divided by n minus 1. So standard deviation is equals to square root of summation of the squared x minus correction factor divided by number of cases minus 1. So our summation of x squared here is 114,670 and our correction factor is 114,005 and our number of cases is 20. So now let's substitute. So now we have square root of 114,670 minus 114,005 divided by 20 minus 1. So the first thing that we need to solve first is to get the difference of summation of x squared and correction factor. So 114,670 minus 114,005 is equals to 600 is equals to 665. So now we have square root of 665 divided by 20 minus 1. So next is we need to get first, or we need to subtract first our number of cases by 1. So 20 minus 1 is equals to 19. So now we have the square root of 665 divided by 19. So, first, we need to divide first. So, 665 divided by 19 is equals to 35. So, we have now the square root of 35. So, to get the standard deviation, we need to take the square root of 35. So, the square root of 35 is 5.916079. So that's our standard deviation.